Hi guys. So let's do some absolute value inequalities. And you remember we had the rules, the properties at the top. And if we had absolute value that's less than, then it's going to be an and. So it's going to encompass all of it. It's going to be all of that stuff in between. And then if it's greater than, the distances are going to be away. So it's going to be an or. So let's go to that first problem. It says solve and check your answers graphically. So first I'm going to solve algebraically. And change the color, maybe green. Okay. So we have 2x minus 4 is going to be less than 4, but it's going to be greater than negative. It's going to be in between negative 4 and 4. Okay. And remember how you solve compound inequalities? You do it to every single side. Oh, I hope you know how to remember how to solve compound inequalities. Please say yes. Divide by 2, divide by 2. X is greater than 0. X is less than 4. Okay, now we have to check. Okay, let's go ahead and graph this. Now, this is made up of 2. And so we have 2 equations. Y equals 4 and y equals 2x minus 4, absolute value. So here is 1, 2, 3, 4. There is going to be my horizontal line right here. Okay, let's go ahead and figure out the vertex, which is going to be, take the 2 out, it's going to be absolute value of x minus 2. So it's going to be 2, 0, there's a plus 0, right? Because you take the 2 out, becomes absolute value of x minus 2 plus 0. So it's going to be 2, 0, 1, 2, 2, 0 right there. And then it has a slope of 2. So I'm just going to go up 2, 1, 2 to the right 1, up 2 to the left 1, up up 2 to the right 1, up 2 to the left 1. Looks about right. Sorry. And so it's going to be this area right here. X has to be between, is that 4 and 0. This area right here. Yes, you must put it in pink. This area right here. Okay. Got it? Okay. Let's go ahead and do the next one. Okay. Now, this is greater than or equal to 1, which means that it's going to be on the outer ridges, outer bounds, outer to the right, outer to the left. So we're going to have 3 minus 2x is greater than or equal to 1, or 3 minus 2x is less than or equal to negative 1. Okay, let's go ahead and solve. Remember, you can't solve or like the way you solve ands, right? Because you can write these as compound inequalities. You can't write these as compound inequalities because it doesn't satisfy both of the conditions. So it's going to be 2 separate things. Does that make sense? Wait a second. Oh, goodness. Oh, goodness. I forgot to flip the inequality sign. Dividing by a negative says U-turn. Okay. And then we have minus 3, and negative 2x, negative 4 divided by negative 2 divided by negative 2x greater than or equal to 2. A U-turn. Okay. So we have, once again, two equations over here. So we have y equals 1. And then we have absolute value of 3 minus 2x equals y. Okay, and we need to figure out the parts that are greater than 1. So I'm going to rewrite this negative 2 plus, 2x plus 3 plus 0 equals y. Let's go ahead and factor out negative 2. That's going to give me a fraction. Okay, absolute value of x minus 3/2. Fun times. Equals y, so 2, and then x minus 3/2 equals y. Okay. So that means that's 1.5. Let's go ahead and graph. X equals 1, 1, 2, 1.5. There's my vertex. I'm going to go up 2, up 1, 2, and right 1, and up 2, and right. Something like that, isn't it? Something like that. Okay, let's go ahead and graph this part right here. And then the other one, make it bigger. 2, the 2, 1, 2, 1 right here, and 1, 1 right here. Satisfies both. It's going to be this area right here. It's going to be that. It's going to be all of that. Not the middle areas. Got it? Got it? I hope so. Okay. How about this one right here? Yes! Don't you love a quadratic? Don't you miss quadratics? Like you haven't seen one in a while and you're like, hey, quadratics. Why not? Okay. So x squared minus 5x less than 6 less than or greater than negative 6. Whoa, whoa. I had to let my dog Leo bark because I'm trapped in this room. And at least he can have his freedom. You see this? We have to break it apart. Okay, so one of them is going to be x squared minus 5x is less than 6. Okay, or implies, okay, let's deal with this situation right here. This implies x squared minus 5x minus 6 equals, not equals, not equals, less than 0. Okay, now we have to factor. Ba-bam. Ba-bam. Okay, x plus x minus, it's 6 and 1. Okay. And then so you can test it, or we know that this has to be less than, so x equals, one of them's negative 1, x equals 6. So we know that it's going to be an and, because it's in between. Okay, it's less than. So x has to be less than 6, but it has to be greater than -1, right? Because if it's less than, it's just like the absolute value distance. I mean, if it's less than 0, it has to be like all consolidated in the middle. And that's why it's a and statement. Let's do the other one. This implies, we'll get in trouble. This implies. Okay. The other one is going to be x squared minus 5x less than 6. I already did that. Duh. Yeah. I have to take time out to sneeze and cough. All that business. 5x. Okay. That implies that 0 x squared minus 5x plus 6. Guys, I'm brand new to this, like all this imply stuff. Okay, because I've never taken IB math until I started working here. And then I just had to study it. And so let's go ahead and figure this out. Okay, so you know that this has to be greater. Or if I rewrite this, it's going to be x squared minus 5x plus 6 is greater than 0. It's different from less than because it's going to be to the outer edges right here. It's going to be the outer edges. It's going to be or statement. So when I factor this, x minus the 3, 2 greater than 0. And I had you guys check x equals 2, x equals 3. It's going to be or statements. Okay. Whoa. So that is going to be greater than this. X has to be greater than 3, or x has to be less than 2. Yeah, or is that too confusing? Let me write it the other way. X has to be less than 2, or x has to be greater than 3. The other ways. So all of that, okay, all of that, we have the unions or the intersections of that, and then we have the unions of the or statement. Okay, so let's try to make sense of this, because it has to be all of these sets. It has to be between -1 and 6, but it has to be less than 2, or it has to be greater than 3. It has to satisfy all these conditions. So if I look at -1 is less than x is less than 6, and I apply this x equals x is less than 2 to it. Okay, now that's going to change the 6 to a 2. -1. It is going to become more restrictive because of the fact that this has to satisfy, the answer has to satisfy this intersection and this union right here. Okay, and then if I look at the rest of it, -1 is less than x is less than 6. Now, this -1, and I add the x is greater than 3. The -1 could change, and it has to be between 6 and 3. If I graph this, and you have quadratic, well, x squared minus 5x, the absolute value of it, and y equals 6. This y right here. It's kind of like a funky graph. It's a quadratic, but then at the end it looks like a kind of a absolute value function. So let's go ahead and make this 1, 2, 3, 4, 5, 6. Hey, we can get that horizontal line on there real good, huh? Okay, now let's go ahead and figure out that quadratic. Okay, so you know that that's x and then x minus 5 absolute value. So it's going to be x equals 0. And it's going to be x equals 0, x equals 5. 1, 2, 3, 4, 5. Okay. And then the vertex is going to be in the middle. 1, 2, 3, 4, 5. So 1, 2. X equals 2, 5. 2.5. Ah! Is it like 2.5? I don't want to do 2.5. In between 0 and 5 is 2.5. Why? Okay, 2.5. X equals 2.5, which is 3 halves. No. See? 5 halves. 5 halves. Okay, and then I'm going to put it back in. And then 5 halves squared minus 5. 5 halves equals y. There we go. 25 over 4 minus 25 over 2 y. Okay, and then that's 25 minus 50 over 4 equals y. Negative 25 over 4. Negative 25 over 4 is, what is negative 25 over 4? I don't know. Let me go ahead and get my calculator later. Uh-oh. Between 0 and 5, 2.5, 2.5. Ha ha ha! Store as x. I'm just going to put it the whole thing in. Do I need to do that? Okay, math, absolute value. Okay, and then x squared minus 5x. Voila. 6.25. That's the absolute value. 6.25. So 2.5, 2.5. 1, 2, 3, 4, 5, 6. Definitely above the 6. So we have this business going on right here. And then if you continue, you will see, okay, for example, at 1, 2, 3, 4, 5, 6, 7, and then maybe negative 1. You can put a x equals 6 in there. 6 store as x. Store as x. So we have, go ahead and absolute value math. I was just going to bring the net absolute value, x squared minus 5x. 6. 6 and 6. So it's going to look like this. And negative 1 is going to be 6 here. Ba-bam. It's going to look like this. Okay, and then it's going to go straight up. So when you have this, if it's, you know that 6 has to be greater. 6 has to be greater. So it's all of this underneath here. So it's going to be from negative 1 right here to 1, 2, somewhere here, and then from 3 to 6, negative 1 to 2, and then 3 to 6. So notice that all of that graph is underneath 6 in those areas. So this is the final answer. And, you know, if you don't feel comfortable about boxing work, then don't do it. Okay? Whatever works for you. Now, whoa. Whoa. Yes. You've waited long enough. Your favorite. We have an absolute value. And always, to keep it exciting, a rational function. right? Yes. You've been wondering. You were like, hey, when am I going to see a quadratic? And then you're like, hey, I haven't seen a rational function in a long time. Not that long, just over the weekend. So, once again, I'm going to sketch two things. I'm going to sketch the y equals 1, this part right here. And then I'm going to sketch y equals the absolute value of 1 over 2x minus 1. And don't be scared about graphing things that are rational. All you have to do is figure out the asymptote, right? And then it's going to be the same business. And then just put some points in. And that's all you have to do. Okay, so, hey, but you know what? You can get that y equals 1 perfect, right? I hope so. Look at right here. I'm not happy. I'm going to make it. Okay, that's good. Y equals 1. Let's draw that horizontal line. Hey, you got half of it done. Okay, now let's go ahead and figure out the asymptote for this. So 2x minus 1 equals 0. X equals 1/2. So we have x equals 1/2. So this is 1, 2, 3. 1/2. This is my asymptote right here. And just because that's an absolute doesn't mean that you can have that 0 exist in the denominator. It's still going to be a restriction. It's still going to be an asymptote. Okay. And also y equals 0 is going to be an asymptote, right? So that's going to be the other asymptote. I should have drawn, I'm going to draw this a little bit like this so you could see it a little bit better. I'm going to kind of, sorry. There we go. That's 1 right there. You can clearly see that graph. Happy little graph. Y equals 1. I love horizontal lines, don't you? Yes. Okay, so here's my other asymptote right here. Well, I'm not going to do that because you guys are going to be like, what is she doing? Okay, so those are my two asymptotes. Now I have to figure out where this graph is. Okay. So let's just go ahead and solve the inequality. 1 over 2x minus 1. So 1. Take it out of 2x minus 1. It's going to be, it implies -1. Let's go ahead and split those up. 2x minus 1 less than 1. I like to split it up so you can actually see we have 2x minus 1, 2x minus 1. 1 is less than 2x minus 1, plus 1, plus 1. 2x is greater than 2. 2x is greater than 1. Multiply by 2x minus 1. Multiply by 2x minus 1. 1 is greater than negative 2x. Let's see. Negative 2x plus 1 minus 1 minus 1. Negative 2x greater than 0. Negative 2, negative 2, so 0, U-turn x. So we have two inequalities. So it has to be less than 0 and less than 1. Okay, so seems like, I'm sorry, greater than 1, less than 0. Okay, so if you look at that, there's the asset put on there. We have 1 1. Looks like it's going to be 1, 1. If I put it back into the equation, if I put in x equals 1, 1, 2, absolute value, 1 over 2, minus 1, that's going to be 1 over 1. It's going to be that. And then if I put in 0, 0, 1 over 0, negative 1, value is still 1. So that's the symmetric right there. And it's going to look like this graph, like right here. It's going to look like this. And it's going to look like this. You know, I shouldn't have drawn it in the same color. You really have to take time when you draw. You know? It's not just like a quick thing. It's actually getting to know all the intricacies. It's trying to get to know the function. And remembering all the special details. Okay? Now, it says which part of this graph is this function less than this function. So it's going to be this area right here where x is that. X, it has to be greater than 1, and or x has to be less than 0. Whoa. And that's the thing about graphing rational functions. It's just that you just have to take your time and figure out like all the little points. And you don't even need that many points as long as you find the asymptote and you know where it goes within that asymptotes. Okay, this was 0, 0. So that was graphically, I solved it. And I mean, it should be, we don't shade. I don't think we shade in IB math. Okay. But anyways, that would be an or right here. We don't box in IB math either. Sorry. Anyways. Okay. Good job, guys. Bye.